Why is it that I can track my pizza delivery down to the last second, but when my life is on the line, the ambulance is nowhere to be found? Hello everybody, welcome to TechWithNinad, and today I am showcasing my project SnapBulance. I built this system SnapBulance to treat emergency services as a real-time distributed system, and this system has been built by the tech stack that you see on the screen. Number one, the citizen module. This is where the user, the citizen, logs in. You can see there are multiple options to log in. The user can log in as a patient. Of course, for the development environment, we have given the option to log in as 4 people or sign up as 4 people. But the user will always be the citizen who will be logging as the patient or the citizen. We are using JWT based authentication and Zustand to store the user data in the browser. We are using React TypeScript to make the front end look beautiful, type controlled, as well as feasible. As the users log in, they can see the rides that have been on, and they can update the profile, like they can put in their own data, and they can even insert their blood type, their allergies, etc. So the patient data is always ready and sound. So now let's move towards the booking part. To handle the booking section, we have used WebSockets. WebSockets are internally connected to 4 other modules, which we'll be talking about in the later part of the video. The backend server is built on NestJS, which is a combination of Express.js and Node.js. When the user clicks book ambulance, a socket event is fired towards the NestJS server, which says that I have to book an ambulance. This request is now circulated on the server. Whoever the users are connected to the socket, whoever the entities are connected to the socket, they see this request being fired. It actively broadcasts in real time that a patient needs help. This is seen by the other modules, which we'll be talking about right now. Moving onwards to the driver module. The driver can log in same way as the user did, with their own email and their own password. After logging in, the driver is greeted with their own dashboard. They can see what trips they have been on and their profile as well. The driver dashboard has a simple button to go on duty or go off duty. When on duty, the drivers can see the nearest alerts that are to their location. Now, the sockets are on this end as well. When the driver clicks go on duty, a socket event is fired, which starts listening for every single event on the server. This is where the first event that was fired by the user comes in. The user, which is firing the event of requesting an ambulance, is listened by this socket, which is on the driver's end. Apart from this, we are inserting this data in the database as well, that the driver is going online or offline, by changing their status. With this, the driver's data is also tracked in the database with their status for status enums like offline, busy, or online, etc. Here we can see when the client, which is the patient, fires the socket event of requesting an ambulance, it is directly updated on the driver dashboard. This is done through sockets as we discussed earlier, and this trip is also saved to the database in real time. Now in the real world, this feature should be automated. Emergency services are not a choice, they are a duty. Right now, as we are in the dev MVP environment, I have enabled the option for the driver to accept the booking. But in a real-time environment, it will be automatically assigned to the nearest driver. We are using the browser geolocation and OSRM API to, as of now, track the user and driver locations. We are fetching the nearest driver location using a formula that is coded into the backend of the server. The drivers that are closest to the user's location are now displayed the event that was fired by the socket, which in turn is a trip request that I need an ambulance. After clicking accept ride, the user and the driver both are moving towards the map page. This again fires a socket event that the ride has been accepted, and the user's UI is updated with a trip that is active. This UI is locked until the trip is completed. This is what we've done in the backend using role-based authentication like features, where we're assigning a role to the user if the trip is completed or not. If there's any active trip, they will always see that trip, and if there's an active trip for the driver, they will see that trip as well. So on this screen, you can see both the user and the driver have a chat button. This chat is also implemented by WebSockets. Sockets are firing events back and forth between the user and the driver when they are in a socket room. This room ID is unique and generated only with respect to the trip that they are on. Here, the trip means the actual mission that the driver is on to deliver the patient to the hospital. So this is the actual trip event where we are tracking what is going on. So this chat button will enable the communication between the user and the driver using WebSockets. A future scope here could be directly linking it to your phone so you can call your driver. But as of now, we have kept it to WebSockets, where we are simply trading in chats. These chats are also deposited to the database in real time, as well as they're seen by both the users and the driver. You can see us chatting out there. We have also included the counter of each message just as a small UX design, so the user can see if there's any messages coming or not. With that, we are currently simulating the location of the driver moving towards the user. Here you can see the driver dashboard has a button arrived at patient. Right now, as it is in the dev stage, we cannot simulate a real-time ambulance arriving at a location, but the coding is very simple. We simply check that if the driver location is between 5 meters of the user, using the same logic that we did to actually assign an ambulance, then we can simply pinpoint that the user location has been reached and the driver has arrived to your location. As of now, now, the driver clicks the arrived at patient button, which transfers the status to moving towards the hospital. This in turn updates the user UI as well as the driver UI. Now let's complete this flow. Driver can simply click arrived at hospital. This should again be automated, but yeah, as of now we are in the dev MVP phase, so we will be not automating it, rather we have it as a post request. So the driver sends that they have arrived at the hospital, and then they complete the handover by putting in the necessary details of the patient, the criticality, and whatever requirements they have. So this is the report that can be filed by the ambulance, so they don't need to recollect or recalibrate whatever happened. The drivers and the ambulance crew, who are the experts, can actually pinpoint that this is the condition of the patient, so they can just have the items and whatever required necessities are ready. Moving on, now that we have discussed about the driver going to the hospital, let us discuss something that we have built for the hospitals. So the hospital admin can also have a login. Registered hospitals with SnapBulance will also have a dashboard provided to them on SnapBulance. This dashboard is actually tracking every single trip that is coming to their hospital. Now this in turn means that every hospital can stay prepared for any ambulances that is incoming. There needs to be no more phone call, there needs to be no more messages. The ambulance is directly arriving at the hospital, and this is where the game changes, because now this communication has turned from a two-way to a three-way. One single socket event is being listened by three different people. When the driver clicks arrived at patient, the hospital can see that there is a new ambulance en route to their location. This socket event is fired towards the driver, towards the user, and towards the hospital. This real-time communication ensures that there is no communication gap, which we see in real time where there is no track. We are just playing a guessing game with ambulances. So that eradicates right here in this system design. So the hospitals can finally see that the ambulance is en route, and they can see the live location out here. They can also see the patient status, patient data, as well as what the driver is up to as of now. And with that, the hospitals can easily see whatever is going on. We are again using the OSRM API and WebSockets to do this. An addition here is we are using Redis. We are caching some data in this layer of the application. So when we are fetching hospitals, what if there is a need of 3 drivers going to the same hospital? So why should you go back to your database, calculate that same location routing, calculate that same database indexing, and then send a hospital out to the drivers? So instead, we are introducing the caching layer of Redis. Redis will store the hospitals which are near to the driver by default. So whenever a request is fired or whenever a driver visits a hospital, this Redis will in turn keep this hospital ready for the next requests. So if from the Redis caching layer, if there is a cache hit for any single hospital which matches the validity, which is the nearest to the driver, then it will simply match it and it will send the driver to that location. So now we are saving that 5 to 10 crucial seconds, even minutes of processing time in worst cases, so that we are ensuring a real time and a smooth emergency response system. With wrapping up the hospital module, we finally have integrated something very similar but very small. We have introduced CFR. CFR stands for Community First Responders. These people are certified professionals who can live among communities. They might be doctors, they might be hospital staff who are off duty, or they can be anybody. Primary job of CFRs is to simply respond to such events on foot. When an ambulance is booked, an ambulance is en route, there might be a need of a medical professional, somebody to do CPR, somebody to handle the patient who is in critical condition. During these times, you need trained professionals because they are the need of the hour. Therefore, we are introducing CFR. Every single CFR is also a user, and they can also see the general dashboard. CFRs and the users are the same people. CFRs, however, get an extra dashboard which is called as the CFR dashboard. When a request is fired and the socket is sending the data that I need an ambulance, it is forwarded to the hospital, it is forwarded to the ambulance, and it is also forwarded to the CFR. So now the socket communication has become a 4-way communication. 4 people at once are listening to the socket in real time. This is excessively bridging the communication gap that there is between multiple users, multiple servers, multiple people, and we are ensuring a smooth handover for every single patient. These CFRs can see any sent requests. These CFRs can then assign themselves to that request by clicking the button I will respond. When they will click I will respond, an alert is sent to the user that the CFR with their name is en route to your location for helping you out. So the CFR will be coming to the user's location while the ambulance is en route, and they can choose either to travel with the ambulance or they can stay at the location after ending that mission. This is very helpful for people who are very urgently in emergency but have less crowd support with them. CFRs can be a great way to actually link people with them. And this socket architecture is of course underlyingly running PostgreSQL, which is storing these data very efficiently, very robustly. And with this tech stack, we are officially completing the overview of SnapBulance. Finally, You can find Docker Compose YML and Docker files for each frontend and backend. You can find the GitHub link in the description right below for the repository as well as my profile. Make sure to drop a star on this project. You can even try it if you want to. You can try to fork it and then make your changes as well. I would really appreciate a lot of feedback on the project, and it has been a wonderful ride for the 7 days building an actual system by myself, which is a real-time communication system. If you want a more deeper explanation of the project, you can find the readme.md, which is right below the repository. With that, thank you everybody for watching. Ninad out.